All right, we're going to continue with solving exponential equations by working with the natural or common logs. So we have an exponential of base 5 and an exponential of base 4. We've already isolated the two exponentials, so now we're going to go ahead and multiply both sides by the natural log. Now we're going to use the power rule. We're going to bring this power down in front and this power down in front. So there's our power rule. Now we are able to use the distributive property. We can take the natural log of 5 and multiply it to x, and the natural log of 5 times -2. The same thing can happen on the right side. The natural log of 5 and the natural log of 4 are just constant numbers. So what we're going to get is x times the natural log of 5 minus 2 times the natural log of 5 equaling 2x times the natural log of 4 plus 3 natural log of 4. Now we're going to go ahead and move like terms together. So this term and that term are alike. They both have the x term. So I'm going to bring them to stay on the left side. Then this term and this term are both constants, so I'm going to move those to the right. So I'm going to add 2 natural log of 5 plus 3 natural log of 4. Now there is a common factor. There's an x here and an x there. So I'm going to take out the greatest common factor. So what I'm left with then is the natural log of 5 minus 2 natural log of 4. And then the right side stays the same. What I've done now is I've isolated this x term. So it's going to stay on the left side. And then the right side we're going to divide both sides by this parentheses. Be careful if you type this all into your calculator. You may want to pause and just check to see if you get the same answer as mine. You're going to get approximately -6.34. You would want to put a bracket here and a bracket there, and then these are going to be parentheses. All right, solving again for an exponential equation using the natural or common log. So we have an exponential equation. This is what we consider a quadratic form. And we're going to use substitution. So e to the x, and I don't want you to write this part down, squared is e to the 2x. So I write it like that. So I'm just changing this 2x to ex raised to the second power. And then minus 4 e to the x plus 3. What we're going to do is we're going to factor this quadratic equation, but we're going to use u substitution. We're going to let u equal e to the x. So this e to the x becomes a u, and then it's squared. Minus 4, this e to the x becomes a u, and then plus 3. Why we use it is it makes it a little easier to see factoring rules. So this is a quadratic trinomial leading coefficient of 1. So what are the factors of 3 that add to negative 4? Well, that is negative 3 and negative 1. So what we're going to do now is we're going to replace the u with what it represents, e to the x. So we factored this quadratic exponential. Now we're going to use our zero product property, and we're going to set each factor equal to 0. So I have e to the x minus 3 equaling 0, and e to the x minus 1 equaling 0. Now we solve them separately for x. I'm going to isolate that first e to the x by adding 3 to both sides. And then I'm going to take the natural log of both sides. The natural log and the base e exponential cancel out. So our answer so far exactly is the natural log of 3. The second equation we undo by adding 1 to both sides. We take the natural log of both sides. The natural log and the e cancel out. We're left with x equaling the natural log of 1. Now there is a property that says the natural log of 1 equals 0. So here are our two solutions. I did put in our notes what this graph looks like graphed out. There are two x-intercepts. One of them is at 0, and the other one is at approximately 1.0. What is 1.0? Well, that's approximately the natural log of 3. So here is your x-intercept and your x-intercept, and you would type this into your graphing calculator and find those x-intercepts.